This video is for General Maths Specialist. It comes out of Chapter 6, Vectors, and it's the Scalar and Vector Resolutes. Remembering scalars are magnitude only, or size. Vectors have magnitude and a direction. Resolutes are bits in one direction and bits in the other direction, so we can break them into two parts or pieces. Okay, if I had two vectors, vector A and vector B, and I placed them together with their tails together, then I could break vector A into two bits. One bit that is in the direction of vector B, and the other bit that is perpendicular to vector B. So that gives me my two bits. If I was only talking about the size, that is the scalar component, then the bit that is in the direction of B is A dot B hat, or the dot product of A and the unit vector B. And because I have two vectors, well, I can work out this is the magnitude of A squared minus the magnitude of A dot B hat squared. Because they're scalars, Pythagoras' theorem will tell me that this side is that side squared, subtract this side squared, then take the square root. If I was to consider these as being vectors, then I can break A into this vector, and this vector will be A dot B hat by B hat. That is, this is its size, its direction is in the direction of B, but I want to multiply it by the unit vector so that it stays this magnitude. And then to get what this is, because I have this vector backwards and that vector, it's going to be A minus A dot B hat B hat. This is what the scalar, that is just the magnitude, this is the vector. If I had another vector, for example, vector A and vector B, I could break vector B into two components. There's a component of vector B that is in the direction of A, and there is a component of vector B that is perpendicular to A. And the vector resolute would be B dot A hat, and this would be B minus B dot A hat. So what we're trying to do is we're trying to break vectors as parts of vectors that are in the direction of or parallel to and away from. What if the vectors were going in different directions? For example, if this was vector A and that was vector B, then there's a component of vector B that is in the same direction as A, and there's a component of vector B that is perpendicular to A. So that this would be B dot A hat, if I'm looking at the vector resolute, and this would be B minus B dot A hat. In the next video, I'll do a couple of examples out of 5.8.